This video is on logarithmic equations and how to solve them. Now, the basic idea behind logarithm or logarithmic equations is to exponentiate on both sides. With exponential equations, we took the logarithm on both sides. Here we take the exponential on both sides. I'll do a set of examples to show you how we could solve log equations. So here's my first example. So for x, and we have log base 4 x cubed plus 11 equals 3. I see log base 4, so I must be exponentiating to the power of 4 on both sides. So I'm going to raise both sides to the power of 4. And the 4 and log 4 will get cancelled because they're inverses of each other, leaving only x cubed plus 11, which would equal 4 cubed, and 4 cubed is 64. Subtract 11 on both sides. X cubed would be 64 minus 11, which would be 53. So x cubed is equal to 53, so x must be equal to the cube root of 53, or 53 to the 1/3 power, and that is our solution. Example 2. Solve for x again. This time we have natural logarithm of x plus natural logarithm of x squared equals 3. Now, when you have multiple logarithms, the first thing that you have to do is to combine all of them and simplify the expression, just like you would do with any algebraic equation. Simplification is a good thing. So I could use the multiplication rule of logarithms because there's a plus sign and there are no constants in front of the logs, so I could combine them and write it as natural logarithm of x times x squared equals 3. But x times x squared is x cubed, which would equal 3, so natural logarithm of x cubed would equal 3. We all know that natural logarithm is nothing but log base e of x cubed equals 3. Now, since I see a base e, I have to raise to the power of e on both sides. So log base e x cubed would be in the power of e, which would be equal to e cubed. The e and the log e are inverses of each other, and they would sort of cancel, leaving you with only x cubed equals e cubed. If you take the cube root on both sides, x would be equal to e cubed raised 1/3, which should mean the solution is e. Numerically, that is 2.7182. Example 3. Solve for x, and let's say we have log base 3 of x plus 2 times x minus 3 equals 2. When you have a quadratic equation or a factor form inside the logarithm, it is not wise to split it up using the multiplication rule of logs. The expression is actually in a very simplified form, so we have to keep it in the simplified form and proceed as is. So I see a log base 3, so I'd raise it to the power of 3 on both sides. and that would give me x plus 2 times x minus 3 equals 9. The 3 and the log 3 would get cancelled. Now you have x plus 2 times x minus 3 equals 9. FOIL, we would get x squared plus 2x minus 3x minus 6 equals 9. Subtract 9 on both sides, we'll get x squared plus 2x minus 3x minus 15 equals 0, which is x squared minus x minus 15 equals 0. That is actually a quadratic equation, and we know how to solve a quadratic equation easily. We use the quadratic formula. A is 1, B is -1, and C is -15. So minus B is minus of -1, plus or minus square root of -1 squared, minus 4 times A times C over 2 times A, which would give us 1 plus or minus square root of 1, minus 4 times minus 15 is plus 60 over 2, which would mean we have 1 plus or minus square root of 61 over 2. So x would have two solutions, 1 plus square root of 61 over 2, and x would equal to 1 minus square root of 61 over 2. And those are our two solutions for this problem. And here is example 4. Again, we solve for x, and we have log base 2 of 3x plus 5 minus log base 2 of 2x minus 5 equals 0. This expression is in an expanded form, and we could combine this. And if we combine it, we can very easily see that this is a base 2 log and base 2 log. So we'll have log base 2 of 3x plus 5 divided by 2x minus 5 equals 0. I see a log base 2, so I must exponentiate to the power of 2 on both sides. So 2 raised log base 2 3x plus 5 divided by 2x minus 5 equals 2 raised 0. These will get cancelled, leaving 3x plus 5 over 2x minus 5 equals 2 raised 0. But any number raised to the power 0 is 1. By multiplying by 2x minus 5 on both sides, we will get 2x minus 5 times 3x plus 5 over 2x minus 5 equals 2x minus 5. These two terms would get cancelled, leaving 3x plus 5 is equal to 2x minus 5. Subtract 5 on both sides and move the x's to one side. We will have minus 5 minus 5. 3x minus 2x is x, minus 5 minus 5 is minus 10. Therefore, the solution is minus 10. Here is example 5. Solve for x. Let's say we have log of x squared plus 10x minus 39 minus log of x minus 3 equals log of 10. Again, we have an expression that is in an expanded form on the left hand side, so let's combine that. You can move this log 10 to the other side and combine it, or keep it on the right hand side and proceed to solve the problem. I'm going to keep it on the right hand side and proceed to solve the problem by simplifying the left hand side, having log x squared plus 10x minus 39 divided by x minus 3 equals log 10. But log is base 10, so log base 10 of 10 would just be 1. And let's see if we can simplify the term that is inside the log, which is x squared minus 10x, plus 10x minus 39 over x minus 3 somehow. Could we factor this? I believe we could factor that. We could factor x squared plus 10x minus 39 as x plus 13 times x minus 3. Now if you forward it, you will get x squared plus 10x minus 39. Now the x minus 3 and x minus 2 would get cancelled. Now, could you have proceeded without simplifying? Yes, you could have, but it would result in a lot of algebraic work later on. We don't want to do that. In mathematics, whenever you get a chance, you simplify. So you have log base 10 of x plus 13 equals 1. I see a log base 10 here, so I've raised to the power of 10 on both sides. So the log base 10 and 10 would get cancelled. So you have x plus 13 equals 10, and x would be equal to 10 minus 13, which would mean x is equal to negative 3. Now, that would be my last problem on logarithmic equations, and keep in mind exponential equations are solved by taking logs on both sides. Logarithmic equations are solved by taking exponentials on both sides. What logarithm to choose and what exponential to choose is always determined by the base that is involved in the problem. To succeed in all of these problems, you must be very confident with the properties of exponentials and the properties of logarithms. And if you're very comfortable with those, solving these problems are quite straightforward. I hope you can understand logarithmic equations better. Thank you for watching the video.